Hi, this is Professor Merrill-Lichty. In this video, we're going to talk about confidence intervals for the mean, and this is the second part of a two-part series. In the last video, we assumed that we knew what the standard deviation sigma was, and so since we knew what that was, we were able to use a z-distribution to find the cutoff values or our estimation error. And you might say, well, that's not that realistic because if I don't know what the mean mu is, how am I supposed to know what sigma is? And so more commonly, we are going to use our sample data to estimate the sample standard deviation S and use that in place of sigma. When we do that, we get an additional layer of uncertainty in the problem. And so in other words, we're not just uncertain about mu, but we're also uncertain about sigma. So our point estimator will still be our point estimator, but our interval is going to be a little bit wider, and because of that we're going to use, instead of a z-distribution, we're going to use what's called a t-distribution. So here's an example to illustrate what's going on. We have a sample of 9 student records, and these are SAT scores, and here they are: 9, 10, 11, 45, and so forth. And if we assume that the SAT scores follow a normal distribution, we can find a 95% confidence interval for mu, or the average SAT score for all students at the university. So based on this data, we see that there are 9 observations, and just plugging into a calculator we get x bar is 1106.11, and the sample standard deviation S is 195.89. So the confidence interval formula that we're going to use is very similar to the one we had in the last video. X bar plus or minus t. It was a z there, but since we don't know, we can't use z because of the additional uncertainty. We're going to use a t times s over the square root of n. Previously we had sigma over the square root of n, but again we don't know sigma, so we're going to use s instead. And the t value comes from a random variable that's very similar to the normal distribution, but it's one that's indexed by what's called degrees of freedom. We'll talk more about that later in the course, but just know that for an unknown mean, when sigma is unknown, the t-distribution is going to have n minus 1 degrees of freedom. So in this case we'll have 8 degrees of freedom, and we want a 95% confidence level. So the question that we have is, what are the values that have 2.5% of the area to the right, 2.5% of the area to the left, and a t-distribution on 8 degrees of freedom? Well, we have several avenues that we can go by to get that number. The first one is to use what's called a t-table, and this is somewhat similar to a normal table, although it's laid out a little bit differently, and that's because there are lots of different t-distributions. And so we would go down here to 8, that's the degrees of freedom, and we know that we want our upper tail probability to be 2.5%, so that's going to take us to that column, and so we get a value of 2.306 for our t value. So we just plug that number in, and all the calculations are basically the same as what we did last time. We get 1106.11 plus or minus 150.57, and that gives us an interval of 955.54 on the low end and 1256.68 on the high end. And so we can say that we're 95% confident that the mean SAT score for all students at the university is between 955 and 1256. Now you might say that's a pretty big range, and it is a very big range, about 300 SAT points, which may not be that informative, but that's what you get when you have a small sample size. So this is the plug and chug way to do this problem, and you certainly can do it that way. What's easier, to use software. In Minitab, if you go to Stat, Basic Statistics, one sample t, you will see this window pop up. We can either use the samples in columns, so if I want to just type the data into a column and then say that's the column, use that data and calculate the mean and the standard deviation, we can do it that way. But if we've already got the data summarized, as is in this case, we can just plug those numbers in. We have a sample size of 9, mean of 1106.11, standard deviation of 195.89. Under the options button, if we click that, we see that we can change the confidence level. So here we've got it at 95%, but if we wanted 99% or 98% or some other value, we can put it in there. And then where it says alternative, we'll talk about hypothesis testing a little bit later in the course, so we're not going to worry about that for now. But plug those things in, push OK, OK, and we get 95.5 and 1256.7, and those are the same things that we had, except for only 2 decimal places. So let's summarize what we've done here. Regardless of whether we have a z or a t, we need to have x bar as at least approximately a normal distribution, which means the population must be normal or the sample size must be greater than or equal to 30. And then if the population standard deviation sigma is known, then we're going to use the z in order to calculate the confidence interval. And this turns out to be less common. If the population standard deviation is unknown, then we're going to use the t and estimate sigma with s.